Hi everyone! In today's lesson, we'll be talking about how to convert from degrees to radians. Here's today's FLT. Given an angle, I will be able to convert from degrees to radians. So first off, let's talk about what radians are. So we've been looking at different types of trig ratios, and all of them have a theta at the end. So it's always like sine of theta, cosine of theta, or tangent of theta. So it's always like something of theta, and theta represents an unknown angle measure. And there are actually two types of units we can use for this angle theta. So thinking outside of trig ratios, for example, if you're talking about height, you can describe it in inches, you could describe it in feet, centimeters, meters, and if you're talking about weight, you can talk about it in pounds or kilograms. So there are two different types of units for angles as well. So one unit we've familiarized ourselves with is degrees. So for example, we've been looking at like sine of 45 degrees or cosine of 32 degrees. So one unit we've been using to describe angles is degrees. Today, we'll be learning about a new type of unit called radians. What exactly is a radian? Think about what the word radian might sound like. So radian kind of sounds like radius. The radius is the distance from the center of a circle to any point on its circumference. So it's basically the distance from the center of a circle to any point on its border. So for example, let's say I have a circle here, and here's the center of that circle. This line segment right here is the radius of a circle. Notice how it goes from the center of the circle to a point on its border, or the circumference. So this is called the radius of a circle. And how does this relate to the idea of radians? So a radian is the angle made when the radius is wrapped around the circle. What exactly does this mean? So here's a fun visual. Notice how the radius wraps around the circle. This creates an angle, and the measure of this angle is 1 radian. So the radian is basically the arc length equal to the length of the radius. And arc is just a fancy way of saying curve. So 1 radian is basically the angle measure created when the radius is wrapped around the circle. It's like placing the length of the radius on the border. So here's another cool visual thing I found. Notice how 1 radian is the same as the length of the radius of this circle. So this is 1 radian. And I can increase this. So let's make it something random like 1.78 radians. Again, radians represent angle measure. So the angle here measures 1.78 radians. What if we make it 2 radians? So this is the length of 2 radiuses or radii. What about 3 radians? Notice how it almost wraps around half of a circle, but not quite. This is where the idea of pi comes from. So pi is approximately 3.14. And notice how if you have pi radians, you create an angle that wraps around half of the circle. So 1 pi radian equals the angle measure of going halfway around the circle. Now what if we go 2 pi radians, so about 6.28 radians? Notice now we wrap around the entire circle. So 2 pi radians represents the amount of angle needed to wrap around the circle. Okay, so let's go back to this idea. 1 pi radian is the angle that represents going halfway around the circle. And when we think back to degrees, how many degrees does it take to go halfway around a circle? So how many degrees would this be? This would be half of 360, so 180 degrees. And we also talked about the unit radians. So to go halfway around a circle, you need to move 1 pi radians worth. So degrees and radians are both ways to represent angles. So they're both units of measure for angles. So today we're going to convert from degrees to radians using this fact that 180 degrees equals 1 pi radian. So make sure you have this written down in your notebook, highlight it, bold it, write it in different colors. 1 pi radian equals 180 degrees. And we'll be using this idea to convert from degrees to radians. All right, so let's look at how to convert from degrees to radians. Before we look at conversions of angle measures, let's look at a more generic example to see how to convert units. So we're going to convert 60 inches into feet. So maybe I have a 60-inch TV or something, I wish. But we're going to convert this into feet. So let's start off by thinking of the relationship between inches and feet. So what do we know about the relationship between these two units? So we know that 12 inches equals 1 foot. So if you have 12 inches, that's the same thing as saying you have 1 foot. Let's use this idea to convert inches into feet. So right here, I'm setting up a T-chart, which you may have seen in chemistry before, but don't worry if you haven't. So I start off with 60 inches, and I want to convert into feet. So in the bottom area, in the denominator, I put what I want to cancel out, and in the top, in the numerator area, I put the unit of what I want to end up with. And we know that 12 inches equals 1 foot, not the other way around. So here we can cancel out the unit inches. So we're left with 60 times 1 foot over 12. Notice how the unit inches has disappeared because we were able to cancel it out. This is just the same thing as 60 feet over 12, which simplifies to 5 feet. So we were able to convert from inches into feet. And although 60 inches and 5 feet look very different, they're actually the same thing, just written differently. So we were able to convert from 60 inches into 5 feet. And so in the upcoming examples, we'll be converting angles. We'll be converting from degrees to radians in a similar manner. For our first example, we're going to convert 30 degrees to radians and write it in simplest form. So we're going from degrees to this new unit, radians, and we have to make sure at the end that it's in simplest form. So we have to make sure to reduce. So let's set up our T-chart. We start with 30 degrees. And so at the bottom, we have the unit that we started with, so degrees. And at the top, we write the unit we want to end up with. So radians, in short, we can write as RAD, rad. And what's the conversion factor? We know that 180 degrees equals 1 pi radian. Notice here, we can now cancel out the degrees. So we've canceled out the degrees unit. We're now left with 30 times 1 pi, so just 30 pi radians, or rad, over 180. Notice how the degree unit has disappeared. I can simplify this by finding the greatest common factor of 30 and 180. The GCF is actually 30, so we're going to divide both the numerator and denominator by 30. We're left with 1 pi, or just pi radians, over 180 divided by 30, which equals 6. And feel free to use your calculator here. Let me rewrite this a little bit. We have pi over 6 radians. So we were able to convert from degrees into radians using the fact that 1 pi radian equals 180 degrees. And the usage of pi tells us that we're working with radians, so you actually don't have to write the unit. You can just write it as pi over 6. So we were able to find out that 30 degrees, written in radian form, is pi over 6. Again, they're the same thing, just written differently. Let's say you weren't able to find the greatest common factor right away. No worries, you just have a few more steps to do. So let's say you notice that 10 is a common factor, so you divide both the numerator and denominator by 10. We get 3 pi over 18. And then I notice that we can also still divide by 3. And I end up with pi over 6, the same answer. So it's okay even if you can't find the greatest common factor right away. Finding the GCF does help us simplify quicker though. Alright, so let's look at our second example. Convert the angle to radians in simplest form. This time we'll be converting 45 degrees into radians. And I'm going to write this out a little differently, so I'm not going to use the T-chart, but it's going to be the same idea. So definitely use the one that you feel more comfortable with. So we're starting with 45 degrees. And we want to convert into radians. So in the denominator, we have degrees, and in the numerator, we have the unit we want to convert to, radians. We know that 180 degrees equals 1 pi radian. So it's basically the same as a T-chart, just written differently. The degrees will cancel out, so we have 45 pi radians over just 180, so we don't include the degrees. Notice how we can simplify this fraction a little bit. So let's find the greatest common factor of 45 and 180. The GCF is actually 45, so let's divide both the numerator and denominator by 45. Again, feel free to use a calculator. We have pi over 180 divided by 45, which equals 4. So we have pi over 4 radians. And again, I'm writing the unit for now, but in your final answer, you don't have to include it. So just pi over 4. So this tells us that 45 degrees is the same thing as pi over 4 radians. And maybe you weren't able to find the greatest common factor right away. That's totally fine. So we started with 45 pi over 180. And maybe you noticed that 5 is a common factor. So you were able to reduce to 9 pi over 180 divided by 5, which equals 36. And then you notice you can still reduce. Now let's divide both numerator and denominator by 9, and we get pi over 4. So although it required a few more steps, we were still able to end up with the same answer. And then this is just a quick visual of what the angle looks like. So 45 degrees is somewhere around here. And so this also means that pi over 4 is also represented visually like this. So although degrees and radians are ways to express the angle differently, the 45-degree angle and the pi over 4 angle are still the same because we simply converted between the two units. All right, for example 3, let's convert 60 degrees into radians. So here we start off with 60 degrees, and we're going to convert it using the conversion factor of degrees and radians. So we know that 180 degrees is the same thing as 1 pi radian. These degrees will cancel each other out, so we are left with 60 times pi radians over 180. The greatest common factor of 60 and 180 is actually 60, so we're going to divide both the numerator and denominator by 60. In the numerator, we have 1 pi, or just pi, and in the denominator, 180 divided by 60 is 3. So we've converted to pi over 3 radians. Again, you don't have to necessarily write the unit radians, so we're simply left with pi over 3. For example 4, we're going to convert 120 degrees to radians. So go ahead and try this on your own and then press play when you're ready. So we start off with 120 degrees. And we're going to multiply the conversion factor. We know that 180 degrees equals 1 pi radian. Notice now we can cancel out the degrees. So now we're just left with 120 times pi radians over 180. The greatest common factor of 120 and 180 is 60. So we're going to divide both the numerator and denominator by 60. Again, don't worry if you can't find the GCF right away. This simplifies to 2 pi radians over 3. So we converted from 120 degrees to 2 pi over 3. Think back to example 3, where we worked with 60 degrees. Notice how 120 degrees is double that amount. Notice how even in the radians, we doubled from pi over 3 to 2 pi over 3. Let's look at a few more examples. Here, we're going to convert from 300 degrees into radians. So we start off with 300 degrees, and we're going to multiply by the conversion factor. We know that 180 degrees is the same thing as 1 pi radian. The degrees, these units, will cancel out. So I'm left with 300 pi, and then radians, over 180. What's the greatest common factor here between these two numbers? it's 60. So we're going to divide both the numerator and denominator by 60. This fraction will reduce to 5 pi over 180 divided by 60, which equals 3. So 5 pi over 3. Here's the last example for today. We're going to start off with 405 degrees and convert this into radians. So again, 180 degrees equals 1 pi radian, so we're using this conversion factor. The degrees will cancel out. So I have that 405 pi radians goes over 180. And the greatest common factor here is a little hard to find, but it's actually 45. So we're going to divide both the numerator and denominator by the GCF. So this will reduce to 9 pi over 4. So we go from 405 degrees to 9 pi over 4. And what does this look like on an actual coordinate plane? So 405 degrees is basically going over a full circle. So it's like the 360 degrees plus a little bit extra. And so going 9 pi over 4 radians is basically going full circle plus a little extra. And so for this example, 405 degrees, if I rewrite this, it's basically telling me that I go a full 360 plus another 45 degrees. So here's a quick review for today. A radian is the angle made when the radius is wrapped around the circle. And 1 pi radian equals 180 degrees. Today we use this conversion factor to convert from degrees into radians. Next time we'll be going the other way around, converting from radians into degrees. Awesome job today, and please remember to submit your notes on Canvas.